3D printing is an incredible technology that gives you the power to make virtually anything right from on top of your desk at home. But what happens when you need a wider variety of materials in your projects? For instance, take this Arduino-based mini heat press machine which I made to heat seal small things up to about 220 degrees Celsius. Or this wooden handle that I made for an antique cooking pan that I bought overseas. Naturally, you can't make these things with 3D printing alone. So recently, I finally took the step of buying my own hobby CNC machine. After putting this machine together, I am really excited to make my first ever project which combines 3D printing, wood, metal, and electronics. And of course, I wanted you to be part of my journey, so let's jump right in. I thought a good place to start would be making some sort of a logo prop for my channel. I really like gears, but I wasn't sure what sort of design to go for. So I went over to ChatGPT and asked it to generate some hybrid wood and metal gears for me. Here's what it came up with, and honestly, that's not actually too bad. I like the half metal, half wood thing going on here, so let's just go with that. Alright, that's enough information for me to go ahead and make a quick 3D model in Rhino. Once the main modeling is complete, we need to split this into two and turn one half into something that looks a little bit more like wood. Rhino isn't the best place to do that, so I'm gonna head over to my favorite 3D sculpting tool, ZBrush. Here I'm just going over the model and creating some unevenness using mainly the Damien standard brush. Okay, with that done, we can now bring everything back into Rhino and take a look. It's looking pretty good, and I think we are ready to put our new CNC machine to the test. Before we can actually make anything on our CNC machine, we first need to generate the milling files, and we're going to do that using Fusion 360. I'm going to start with the wooden half because I feel like it should be a lot easier to cut wood than metal, and also because I've never seriously done this before and I'm scared of screwing something up. So here's our 3D model. Honestly, I had absolutely no idea what I was doing here. I just went around searching for videos on YouTube and other tutorials, but I stuck with it and just kept playing around with different settings, and after about a week's worth of time, I finally had a breakthrough when I tried generating a toolpath, and Fusion 360 actually did it. So if you want a full beginner's guide on how to do all this step by step, please let me know in the comments below. At this point, it all looks pretty good to me. Fusion 360 has a really good toolpath visualization tool. So I've had a look at it and yeah, it looks pretty good to go. So let's go ahead and get cutting. Here I'm cutting a piece of oak wood that I have been drying for a couple of years. The idea is to cut it to a size that's thick enough for the gear design, but also small enough to fit on the CNC machine. Once it's on the machine, it's time to get cutting. The software I'm using at the moment to load the G-code files is called Candle. It's a little bit, well, old looking, but I found it a good place to start because I'm just a beginner. I wasn't really sure what the best tool is, so I just started off with a 3mm diamond end mill. I am pretty sure this is not the right tool for cutting wood, but let's see how it goes anyway. Okay, after the roughing pass is finished, I moved on to the finishing pass. For this, I changed tools over to a 0.5mm diameter tapered ball end mill. And after about another hour and a half of cutting, the model is finally finished. And honestly, I am super impressed. I mean, just have a look at all of these details that it managed to carve out. That is fantastic, and yeah, that's just crazy. So now I have a little bit more confidence. I'm going to make a slightly bigger version, but using a different wood. I used oak for the previous one, so now I'm going to move on to sycamore because it has a plain grain, and that's going to make it a lot easier for us to wood burn details into later on. I have also learned that a 2-flute flat end mill is better for cutting wood, so I'm going to use this one for the next cut. There's still some flaky edges, but that's easy to fix with some basic hand filing. And here's the wooden half ready for decorating. Although the details are carved really well by the CNC machine, we need to do a little bit more work to bring out the cracks and crevices, otherwise when you look at it from a distance it's just going to look kind of flat. So let's pull out our wood burning tools and get to work. The main idea is to darken the crevices where you would expect to find dust gathering over the years. Then you go around and darken the wood with some low temperature burning. And finally, the magic happens when you apply some linseed oil. Alright, and here it is. The final wooden carving is complete. Next, we need to repeat the same process with the metal half. This required a little bit more work, but is essentially the same thing. I prepare the aluminium stock myself, so if you're interested in how I do that, please have a look in the description below for a link to that video. I was really surprised at how this machine handled the carving. Sure, it took forever, but for a machine that's apparently not designed to carve deep into aluminium, which is the impression I got from the Amazon listing, I thought it did a pretty incredible job and I'm super pleased. Unfortunately though, the job did end abruptly, but that's not because of the machine, that's because I don't have any vacuum system to pick up the mess. So some metal chippings accidentally triggered a limit switch on the machine about 23 hours into the job. And that was really annoying. But on the bright side, it did get through most of it, and I was able to finish off the rest using a bandsaw. So, crisis averted. And here's the final metal piece. Looking at the two halves together, I think the design has been implemented pretty well. It definitely gives off the traditional versus modern engineering vibe, and that's exactly what we were going for. Okay, and now let's bring this whole thing to life with some 3D printing and electronics. I thought it would be really nice to have a sci-fi looking box that lights up and also has a real-time subscriber counter on an LCD screen. For the middle, I also want a light between the metal and wooden halves of the gear, as well as another light that goes around the entire head unit behind the gears. So here's the circuit diagram that I drew up in order to make all that happen. The main control is happening through a Wemos D1 Mini microcontroller, which connects to my local Wi-Fi and uses YouTube's API to get the subscriber count every 30 minutes. This subscriber count is then displayed on a 2-inch TFT screen, which connects to the Wemos via SPI. Since my LED strip is not dimmable, I'm going to use a logic level MOSFET to control its brightness. This 10 kilo ohm resistor is also very important because it pulls the MOSFET gate down to ground and keeps the LED lights off while the microcontroller is booting up. I then used ChatGPT's help once more to write out the code for me according to the logic that I had designed. And after that, it was time to create a schematic and route the circuit board using Altium Circuit Maker. Next up was milling the PCB, which was done on the same CNC machine that we made our wood and metal pieces on. Again, if you would like a video detailing the steps on how to do this, please let me know in the comments below. And that's looking absolutely amazing. I really like the soft starting on the lights, which is only possible because of the logic level MOSFET that we used. So let's go ahead and put all the 3D printed parts together and finish this project up. First up is the actual Maker Vibe logo. This is printed in different colors to match the logo here on the channel banner. Now comes the sci-fi box. I chose to print this in Galaxy Black PLA filament to give it a nice looking texture. Once it's all put together, I used an orange coloured diffuser to make our white LED strip give out orange light. This is really starting to look like a sci-fi prop now. All we need to do is put the main screen on with the help of the jumper wires, and install the PCB into the main box unit to secure it in place. And there you have it. That's it. Our first wood, metal, plastic and electronics project completed. Thanks very much for watching, and as always, please let me know what you think in the comments below. I'll see you next time.